Hello and welcome to the Sleepy Physicist. I'm so glad you're here. Whether you're settling into bed, curling up in a favorite chair, or just trying to find a moment of calm in your day, you've come to the right place. This is a quiet corner of the internet where physics gets gentle and wonder puts on soft pajamas. Tonight, we're diving into one of the most beautiful and bewildering mysteries of our universe. When light forgets how to travel. Picture this, a single photon racing through space. At the speed that bears its name, suddenly encounters two doorways side by side for a moment that defies everything we think we know about reality. That particle of light pauses not in space, but in possibility itself. It hovers between being and becoming, between here and there, between wave and particle, as if the universe itself is holding its breath. In that impossible stillness, something profound happens. The very act of asking, "Where are you?" transforms the nature of what light is. And in that transformation, we glimpse something extraordinary about the fabric of reality itself. Now, before we begin, if you enjoy these gentle journeys through the mysteries of physics, I'd be ever so grateful if you tapped the like button, subscribed, or even just left a comment telling me where in the world you're listening from and what draws you to these quantum puzzles. It helps this sleepy little channel grow and reach other curious minds who find wonder in the impossible. What does it mean for light to forget how to travel? Is it possible that the most fundamental constant in our universe, the thing that connects every star to every eye that has ever gazed upward, can somehow lose its way? And if light itself can become confused about its own nature, what does that tell us about the nature of reality? These aren't just abstract questions for physicists in laboratories. They're invitations into a mystery so profound that it challenges everything we think we know about existence itself. Because when we peer into the quantum realm, we discover that light doesn't just illuminate the world around us. It reveals the strange, malleable nature of the world itself. The story begins over a century ago, but it's as relevant tonight as it was when the first quantum pioneers stumbled upon these impossible truths. You see, for most of human history, we had a comfortable relationship with light. We understood it well enough. Sunlight warmed our faces, moonlight guided our paths, candlelight pushed back the darkness. Light traveled from here to there in straight lines at a predictable speed, and that was that. But then something extraordinary happened. Scientists began to look more closely at light itself, not just at what it illuminated, but at the very nature of illumination. And what they found was so strange, so contrary to everything that seemed reasonable, that many of them spent years trying to prove themselves wrong. Imagine you're holding a flashlight in a dark room. You press the button and light streams out in a beam. You can see where it goes. You can trace its path from the bulb to the wall. This is light, as we experience it every day. Purposeful directional traveling from point A to point B, like a cosmic messenger carrying information about the world. But now imagine something impossible. Imagine that same beam of light somehow taking every possible path. Simultaneously, imagine it going straight forward, while also bouncing off the ceiling, while also curving around obstacles, while also passing through solid walls, all at the same time. This isn't science fiction. This is what light actually does when nobody's watching. I find myself wondering sometimes late at night when the world is quiet, whether light knows we're trying to understand it. Whether our very curiosity changes something fundamental about how it behaves. Because here's what the experiments tell us, and this might sound like magic, but it's measured, repeatable science the moment we try to observe light's journey. The moment we set up detectors to see which path it takes, everything changes. The light that was somehow taking all paths simultaneously suddenly picks just one as if our attention collapses infinite possibilities into a single reality, as if consciousness itself reaches into the quantum realm and says, "Choose now." This phenomenon has a name-wave particle duality, but that clinical term doesn't capture the breathtaking strangeness of what's actually happening. When scientists first discovered this, they didn't just find a new property of light, they found evidence that reality itself might be far more fluid, far more responsive to observation than anyone had ever imagined. Let me paint you a picture of the experiment that changed everything. It's called the double slit experiment, and it's so simple. A child could set it up, yet so profound that it continues to puzzle the greatest minds in physics. Imagine a wall with two narrow slits cut side by side like two doorways in a fence. Now imagine shooting particles of light photons through these slits one at a time. If light were simply particles like tiny bullets, you'd expect to see two bright strips on a screen behind the wall, one behind each slit. But that's not what happens. Instead, you see something that looks like ripples on water, an interference pattern of bright and dark bands, as if each single particle of light somehow went through both slits, simultaneously interfering with itself. This is where it gets beautifully mysterious, because the moment you place a detector at one of the slits to see which path the photon actually takes, the interference pattern disappears. The light suddenly behaves like ordinary particles, creating just two bright strips, as if the act of measurement itself reaches backward in time and changes the fundamental nature of what light is. I often think about this late at night, staring up at stars whose light has traveled millions of years to reach my eyes. Did that light exist as waves or particles during its cosmic journey? Or does it only decide what it is in the final moment when it strikes my retina, when my brain processes the signal and creates the experience of seeing? But the mystery deepens even further, because scientists have discovered that it doesn't matter when you decide to measure the light. You can set up your detector after the photon has already passed through the slits, after it's already hit the back wall. And somehow, retroactively, the decision about whether to measure seems to influence what the light was doing in the past. This is called the delayed choice experiment, and it suggests something almost impossible, that the future can influence the past, or perhaps more accurately, that our conventional understanding of cause and effect breaks down completely at the quantum level, as if time itself becomes negotiable when we're dealing with individual particles of light. What does this mean for our understanding of reality? If light, the thing that allows us to see the world, can exist in multiple states simultaneously until the moment we observe it, what does that tell us about the nature of observation itself? Are we passive recipients of information about the world around us, or are we somehow active participants in creating the reality we think we're just discovering? These questions lead us to one of the most profound mysteries in all of science, the measurement problem. Why does the act of measurement cause quantum systems to collapse from multiple possibilities into a single reality? Is consciousness required for this collapse, or is any interaction sufficient? Does the universe exist in a definite state when nobody's looking? Or does it remain suspended in quantum possibility until observation forces it to choose? Some physicists have proposed that consciousness itself is fundamental to the collapse of quantum possibilities. Others suggest that decoherence with the environment is sufficient. Still others propose that all possibilities exist simultaneously in parallel universes, that we simply lose access to the other outcomes when measurement occurs. I find myself drawn to the poetry in these explanations. The idea that reality might be more like a conversation between observer and observed, rather than a fixed stage upon which events simply unfold, that perhaps consciousness and cosmos are engaged in an eternal dance, where each influences the other in ways we're only beginning to understand. But let's step back for a moment and consider what this means. Practically, these aren't just abstract philosophical puzzles. They're observations with real-world implications. The strange behavior of light and other quantum particles is what makes modern technology possible. Lasers work because of the quantum properties of light. Computer chips rely on quantum tunneling. Medical imaging depends on quantum effects. Yet even as we harness these quantum phenomena for practical purposes, the deeper mystery remains. Why does light sometimes forget how to travel in the way we expect it to? Why does observation change the nature of what we observe? And what does this tell us about the relationship between mind and matter, between consciousness and cosmos? The double-slit experiment reveals something profound about the nature of information itself. When information about which path the photon takes is available, even if nobody actually looks at it, the interference pattern disappears. It's as if the universe keeps track of what could potentially be known and adjusts reality accordingly. This leads to an even stranger possibility. What if information itself is more fundamental than matter or energy? What if the universe is essentially computational, and particles like photons are simply information processing at the most basic level? This would mean that when light forgets how to travel, it's not really forgetting at all. It's following deeper information, processing rules that we're only beginning to glimpse. Some of the most recent experiments have pushed this mystery even further. Scientists have shown that quantum effects can occur across vast distances, that particles separated by miles or even continents can remain mysteriously connected, such that measuring one instantly affects the other. Einstein called this spooky action at a distance and spent years trying to prove it couldn't exist. But it does exist, and it suggests that our intuitive understanding of space and time as separate, isolated regions breaks down at the quantum level. Perhaps the universe is more interconnected, more holistic than our everyday experience suggests. Perhaps the boundaries we draw between here and there, between past and future, are useful approximations rather than fundamental truths. As we explore these mysteries further, we'll discover that light's strange behavior is just the beginning. There are particles that tunnel through barriers they shouldn't be able to cross, waves that exist in multiple places simultaneously, and effects that seem to propagate backward through time. But before we venture deeper into these quantum rabbit holes, let's pause and consider what we've already discovered. Light, that most familiar aspect of our daily experience, reveals itself to be profoundly mysterious. When we look closely, the beam from your flashlight, the sunlight streaming through your window, the glow from your screen, all of these contain multitudes of possibility that collapse into single realities only when observed. In that collapse from infinite possibility to specific actuality, we glimpse something beautiful and strange about the universe. We inhabit a cosmos where consciousness and matter dance together, where the future reaches back to influence the past, and where light itself serves as both messenger and mystery, carrying information not just about distant stars and nearby objects, but about the very nature of existence itself. The ancient philosophers spoke of light as a metaphor for knowledge, for consciousness itself. And perhaps they were more right than they knew. Perhaps in studying the quantum behavior of light, we're not just learning about photons and wave functions. We're learning about the deep structure of reality itself, about how information consciousness and cosmos weave together in ways that challenge our most basic assumptions about what it means to exist. And this is only the beginning. Our journey into quantum mysteries has barely started. We've seen how light can forget how to travel in straight lines, how observation changes the nature of what we observe, and how the future might reach back to influence the past. But there's something even stranger waiting for us in the quantum shadows. Something that pushes the boundaries of impossibility even further. Imagine, if you will, a particle that needs to cross a mountain, but instead of climbing over it, simply appears on the other side as if the mountain were made of mist. This isn't metaphor. This is quantum tunneling, and it reveals that the universe operates by rules so alien to our everyday experience that they seem borrowed from dreams. Quantum tunneling occurs when particles encounter barriers they shouldn't classically be able to cross. Think of it like this. If you threw a ball at a brick wall, you'd expect it to bounce back. But in the quantum realm, that ball has a chance, however small, of simply materializing on the other side of the wall without ever going through it, around it, or over it. The mathematics tell us this should happen, and remarkably, experiments confirm that it does. But here's where the mystery deepens. When scientists measured how long it takes particles to tunnel through these barriers, they discovered something that challenges one of the most sacred principles in physics. The particles seem to cross instantly, or in some cases even faster than light should be able to travel, as if in the act of tunneling, they briefly stepped outside the normal flow of time itself. I find myself lying awake sometimes wondering about the implications of this. If particles can tunnel through barriers instantaneously, what does that tell us about the nature of barriers themselves, about the solidity of the walls around us, the ground beneath our feet? The very atoms that make up our bodies are mostly empty space, held together by quantum forces that themselves seem to operate outside our intuitive understanding of how things should behave. This phenomenon has practical consequences too. The device you're using to listen to this relies on quantum tunneling. Electrons in computer chips regularly tunnel through barriers that classical physics says should stop them. Flash memory drives work because electrons can tunnel through insulating layers. And the scanning tunneling microscope, which can image individual atoms, operates by measuring the quantum tunneling current between a sharp tip and a surface. Yet despite these practical applications, the deeper mystery remains unsolved. How can particles appear to move faster than light during tunneling without violating Einstein's special relativity? Some physicists argue that no information actually travels faster than light during tunneling, that what we're measuring isn't true superluminal motion, but rather the strange way quantum probability waves behave near barriers. Others suggest that our very concept of travel breaks down at the quantum level, that asking how long it takes a particle to tunnel is like asking what color the number 7 smells. Like a category error that reveals the limitations of our classical thinking rather than any fundamental property of nature. But perhaps the most unsettling possibility is that quantum tunneling reveals something profound about the nature of existence itself. If particles can exist in multiple locations simultaneously until measured if they can tunnel through barriers instantaneously, then perhaps the boundaries we perceive between here and there, between possible and actual, are far more fluid than we ever imagined. This brings us to another quantum mystery that seems to mock our understanding of space and time itself. Quantum entanglement, where particles become so deeply connected that measuring one instantly affects the other, regardless of the distance between them. Einstein famously called this spooky action at a distance and spent years trying to prove it couldn't exist because it seemed to violate the principle that nothing can travel faster than light. But entanglement isn't about particles sending signals to each other across space. It's something far stranger and more beautiful than that. Imagine two coins that are somehow connected, such that when one lands heads, the other instantly lands tails, no matter how far apart they are. This isn't communication in any conventional sense. It's as if the two particles share a single quantum identity distributed across space when scientists create entangled photons and send them to opposite sides of a laboratory, or even to different continents. The correlations between their measurements remain perfect, instant, and mysterious. It's as if space itself becomes irrelevant to their connection, as if they exist in a realm where distance is meaningless and separation is an illusion. I often think about what this means for our understanding of isolation and connection. If particles can remain entangled across vast distances, what does that tell us about the nature of relationships themselves? About the invisible threads that might connect all things in ways we're only beginning to glimpse? Perhaps consciousness itself operates through quantum entanglement. Perhaps the sense of separation we feel from each other, from nature, from the cosmos itself, is a useful fiction rather than a fundamental truth. But entanglement reveals something even more profound about the nature of measurement and reality. When you measure an entangled particle, you don't just discover its properties, you actually create them. The act of measurement doesn't reveal pre-existing information. It generates new reality, as if the universe remains suspended in quantum possibility until observation forces it to choose. This leads us to one of the most beautiful and bewildering aspects of quantum mechanics: the superposition principle, where particles can exist in multiple states simultaneously. Until measured, it's as if reality itself is fundamentally probabilistic, as if the universe is constantly improvising, choosing from infinite possibilities in each moment of observation. Consider a photon in superposition existing as both wave and particle, simultaneously, not switching between states, but somehow being both. Until the moment we look, this isn't just a limitation of our measuring tools or a quirk of very small particles. It appears to be a fundamental feature of reality itself, as if the universe prefers possibility to certainty, potential to actuality, until forced to choose. Some physicists interpret this as evidence that consciousness plays a fundamental role in shaping reality, that the universe exists in a state of quantum possibility until conscious observation collapses it into specific actuality. Others argue that any interaction with the environment is sufficient to cause collapse, that consciousness is irrelevant to the quantum measurement process. But there's a third possibility, one that's both more radical and more beautiful than either of these. What if consciousness and cosmos are not separate phenomena? What if awareness and existence are two aspects of a single underlying reality that we glimpse in quantum mechanics? What if the observer and the observed are not distinct entities, but expressions of a deeper unity that quantum physics is just beginning to reveal? This possibility leads us to some of the most profound questions in all of science and philosophy. Are we discovering the laws of nature or participating in their creation? Is reality something that exists independent of observation, or something that emerges through the interaction of consciousness and cosmos? Do we live in a universe, or do we co-create one through the very act of being aware? These questions become even more mysterious when we consider the delayed choice quantum eraser experiment, where scientists can seemingly reach backward in time to determine whether light behaved as a wave or particle in the past, as if the future reaches back to influence what has already happened, as if causality itself becomes negotiable at the quantum level. In these experiments, photons are sent through a double slit setup, but instead of measuring them immediately, scientists store information about which path each photon took, and then later decide whether to erase that information or keep it. Remarkably, the decision about whether to erase the path Information seems to retroactively determine whether the photons created an interference pattern, even though that pattern was already recorded on a detector. This suggests something almost impossible, that the future can influence the past, or perhaps more accurately, that our conventional understanding of time as flowing from past to future breaks down completely at the quantum level, as if past, present, and future are more like different rooms in the same house, rather than a linear progression from what was to what will be. I find myself wondering about the implications of this for consciousness itself if quantum effects can seemingly operate backward in time. Do our future decisions somehow influence our past experiences? Do the choices we make tomorrow somehow shape the reality we experience today? These questions push the boundaries of both physics and philosophy into territories that feel more like mysticism than science. Yet the experiments are real. The correlations are measurable, and the implications are profound. If time itself is more fluid than we imagined, if the future can reach back to influence the past, then perhaps consciousness itself operates outside the normal flow of temporal causality. Perhaps awareness exists in a realm where past, present, and future are simply different perspectives on a single timeless reality. This possibility becomes even more intriguing when we consider recent experiments that seem to show quantum effects operating at macroscopic scales. Scientists have observed quantum superposition in objects visible to the naked eye, quantum entanglement between biological molecules, and quantum tunneling in photosynthesis and other biological processes. It's as if the boundary between the quantum realm and our everyday world is far more porous than we ever imagined, as if consciousness itself might be a quantum phenomenon, emerging from the strange, probabilistic substrate of reality itself. This would mean that when we study quantum mechanics, we're not just learning about photons and electrons. We're learning about the deep structure of awareness itself. But perhaps most mysteriously of all, we're discovering that the universe seems to be fundamentally informational rather than material, that particles might be better understood as bits of information rather than tiny objects, that reality itself might be computational with consciousness as the universe's way of processing and experiencing its own information. This informational view of reality suggests that when light forgets how to travel, it's not really forgetting anything at all. It's following deeper information, processing rules that we're only beginning to understand, rules that govern not just the behavior of particles, but the emergence of consciousness, the flow of time, and the very fabric of existence itself. As we delve deeper into these quantum mysteries, we discover that every answer reveals new questions. Every solved puzzle opens doors to even greater enigmas. The universe seems designed not just to be understood, but to perpetually surprise us, to challenge our assumptions, and expand our sense of what's possible. And in that endless dance of discovery and mystery, we find something beautiful, a cosmos that refuses to be reduced to simple mechanical explanations, a reality rich with possibility, where consciousness and matter wave and particle observer and observed dance together in patterns too complex for any single mind to fully grasp, yet somehow accessible to wonder, to curiosity, to the gentle, persistent questioning that draws us deeper into the heart of existence itself. But our journey through quantum strangeness has only just begun. We've seen how light can exist in multiple states simultaneously, how particles can tunnel through impossible barriers, and how the future might reach back to influence the past. Yet there are even stranger phenomena waiting for us in the quantum shadows. Mysteries that will challenge everything we think we know about the nature of reality itself. Now imagine something even more impossible than light, forgetting its path. Imagine a realm where empty space itself seethes with invisible activity, where the vacuum that we think of as nothingness turns out to be the most energetic place in the universe, a cosmic ocean of potential that never rests, never sleeps, and never truly empties. This is the quantum vacuum, and it reveals that our most basic assumption about reality, that empty means absent of everything, is spectacularly wrong. The space between stars, the gap between atoms, the pause between your thoughts, all of these seemingly empty regions pulse with an energy so vast and mysterious that it makes the brightest stars look dim by comparison. I find myself staring into dark corners of rooms, sometimes wondering what invisible dramas are playing out in those seemingly vacant spaces. Because according to quantum field theory, every cubic centimeter of empty space contains enough zero-point energy to power entire civilizations. If only we knew how to harness it. It's as if the universe keeps a secret treasury of infinite wealth hidden in plain sight in the very nothingness that surrounds us. But this vacuum energy doesn't just sit there quietly minding its own business. It actively shapes the reality we experience. Virtual particles pop into existence in pairs, lasting for impossibly brief moments before annihilating each other and disappearing back into the quantum foam. These aren't real particles in the sense we normally understand them. They're fluctuations in the quantum fields that permeate all space. Brief borrowings from the universe's energy bank that must be repaid almost instantly. Yet these phantom particles have measurable effects on the real world. They alter the behavior of atoms, change the properties of light, and even create forces between objects that should have no reason to interact. It's called the Casimir effect, and it demonstrates that the quantum vacuum isn't passive emptiness, but an active participant in the physical processes that govern our universe. Picture 2. Perfectly flat metal plates suspended in the vacuum of space, with nothing between them except empty space. Classical physics would predict no force between these plates, but quantum mechanics tells a different story. The virtual particles that constantly appear and disappear in the vacuum have different wavelengths, and the space between the plates can only accommodate certain sizes of these quantum fluctuations. This creates an imbalance. More virtual particles push on the outside of the plates than on the inside, creating a measurable attractive force that draws the plates together. It's as if empty space itself develops preferences, pushing and pulling on matter through the ghostly influence of particles that exist only in the realm of possibility. What strikes me most about this is how it challenges our deepest assumptions about existence and non-existence. If virtual particles that don't really exist can create real forces that move real objects, then what does it mean for something to be real? What's the boundary between the possible and the actual, between the imagined and the experienced? This question becomes even more profound when we consider that some physicists believe these virtual particles might be responsible for the very existence of matter itself, that the stable particles we think of as the building blocks of reality might actually be persistent patterns in the quantum vacuum, temporary islands of stability in an ocean of constant fluctuation. If this is true, then everything you see around you, every atom in your body, every star in the sky, might be nothing more than organized emptiness patterns of virtual activity in the quantum vacuum that have learned to maintain themselves across time. It would mean that matter itself is a kind of illusion, a persistent dream in the mind of the quantum field. But the mystery of the quantum vacuum goes even deeper than virtual particles, because recent experiments have begun to probe what happens when you try to create truly empty space. When you remove all the matter, all the radiation, all the heat, and try to reach absolute nothingness. What remains defies every intuition we have about emptiness, even at absolute zero temperature when all thermal motion should cease. The quantum fields that permeate space continue to fluctuate. These zero-point fluctuations represent the minimum energy that any quantum system can possess. The irreducible restlessness of reality itself. It's as if the universe has a constitutional inability to be perfectly still, as if motion and change are written into the very foundations of existence. These fluctuations aren't just theoretical curiosities. They have profound implications for our understanding of the cosmos itself. Some physicists believe that the zero-point energy of the quantum vacuum might be responsible for the accelerating expansion of the universe. That dark energy, the mysterious force pushing galaxies apart, might simply be the universe's response to the relentless pressure of quantum fluctuations. If this is true, then the fate of the cosmos itself depends on the behavior of virtual particles that exist for impossibly brief moments in the spaces between spaces. It would mean that our universe's ultimate destiny is written in the quantum foam that bubbles constantly at the smallest scales of reality. I often wonder whether consciousness itself might emerge from this quantum vacuum, whether thoughts and awareness might be patterns of organization in the same field that gives rise to matter and energy. Perhaps when we think, when we dream, when we experience the subjective flow of consciousness, we're participating in the same fundamental process that creates particles from emptiness, that transforms potential into actuality. This possibility becomes even more intriguing when we consider that the quantum vacuum responds to the presence of matter and energy. Massive objects warp the properties of empty space around them, altering the patterns of virtual particle creation and annihilation. It's as if consciousness and matter both arise from the same source and both influence the behavior of the quantum substrate from which they emerge. But perhaps the most beautiful aspect of the quantum vacuum is how it reveals the interconnectedness of all existence, because the virtual particles that appear and disappear throughout space don't respect the boundaries we draw between objects, between here and there, between self and other. Every point in space is connected to every other point through the web of quantum fluctuations that permeate the vacuum. This means that the emptiness between us isn't really empty at all. It's alive with possibility, teeming with potential connections that link every atom to every other atom across the cosmos through the invisible medium of the quantum field. It suggests that separation itself might be an illusion, that at the deepest level of reality, everything is connected to everything else through the quantum vacuum that underlies all existence. When light encounters this quantum vacuum, something remarkable happens. The photons don't just travel through empty space. They interact with the virtual particles that populate the vacuum. These interactions are usually subtle, but they can be measured, and they reveal that even light itself is shaped by its journey through the sea of quantum possibility. In some cases, these interactions can cause light to behave in ways that seem impossible, causing it to bend around obstacles through quantum tunneling, or to split into multiple paths that somehow remain connected across vast distances. It's as if the quantum vacuum serves as a cosmic communication network, allowing particles of light to share information instantaneously, regardless of the space between them. This brings us to one of the most profound mysteries in modern physics: the question of whether information itself might be more fundamental than matter or energy. Whether the universe might be essentially computational, with particles and forces emerging from deeper information processing patterns in the quantum vacuum. If this is true, then when light forgets how to travel, it's not really forgetting anything. It's following information, processing rules that operate at a level deeper than space and time. Themselves, rules that govern not just the behavior of photons, but the emergence of space-time matter-energy and perhaps consciousness itself from the quantum information substrate. Recent experiments have begun to probe these deeper layers of reality. Scientists have discovered that quantum information can be stored in the correlations between particles. That information about a quantum system can become distributed across the vacuum itself in ways that make it impossible to localize or destroy. This suggests that the universe might have a kind of memory built into the quantum vacuum itself, a record of every quantum interaction that has ever occurred preserved in the patterns of virtual particle creation and annihilation that fill empty space. Perhaps the vacuum itself is conscious, in some sense aware of its own information content, and actively participating in the computation of reality. These ideas push us to the very edges of current scientific understanding into territories where physics meets philosophy, meets mysticism in ways that challenge our most basic assumptions about the nature of existence. But they also offer glimpses of a reality far richer and more mysterious than we ever imagined. A cosmos where empty space teems with invisible activity, where virtual particles dance at the boundary between existence and non-existence, where information itself might be the fundamental substance from which everything else emerges, and where consciousness might be the universe's way of experiencing its own infinite creativity. As we continue our journey through these quantum mysteries, we'll discover that the strangeness we've encountered so far is just the beginning. There are phenomena waiting in the shadows of physics that will challenge not just our understanding of how things work, but our most basic assumptions about what it means for anything to exist at all. But for now, let us pause and marvel at the quantum vacuum, this invisible ocean of possibility that surrounds and permeates everything we know. This cosmic creativity that transforms nothingness into somethingness, possibility into actuality, emptiness into the fullness of existence itself. And in that transformation, we glimpse something profound about our own nature as conscious beings emerging from and participating in the same quantum processes that fill the vacuum with virtual particles that bend light around impossible corners and that weave the fabric of space and time itself from the gossamer threads of pure information. The ancient mystics spoke of the void as the source of all creation, and perhaps they intuited something that quantum physics is only now beginning to reveal, that emptiness and fullness are not opposites, but dance partners in the cosmic ballet of existence, that nothingness and somethingness are simply different faces of the same underlying mystery. And in that mystery, we find not answers but deeper questions, not certainties, but more beautiful uncertainties that draw us ever deeper into the heart of what it means to be aware, conscious beings in a universe that seems designed not just to be experienced, but to experience itself through us, through our wonder, through our questions, through our endless fascination with the impossible. Perhaps the most haunting aspect of quantum reality lies not in what we can measure, but in what happens in the spaces between measurements, in those quiet moments when no detector watches, when no conscious mind observes. The universe seems to retreat into a realm of pure possibility, where the familiar rules of cause and effect dissolve like morning mist. This is where we encounter one of the most beautiful paradoxes in all of physics: quantum superposition, where particles exist in multiple states simultaneously until the very moment we choose to look. It's as if reality itself is fundamentally shy, comfortable being everything at once until attention forces it to pick a single face to wear. I find myself thinking about Schrödinger's famous thought experiment. Not the cat everyone talks about, but the deeper question it raises about the nature of existence itself. If a quantum particle can be in two places at once, spinning both clockwise and counterclockwise, existing and not existing simultaneously, then what does it mean for anything to have a definite state? What does it mean for you to be sitting exactly where you are right now, listening to these words? The mathematics of quantum mechanics suggests something almost mystical, that particles exist in what physicists call a superposition of states, a ghostly blend of all possible realities layered on top of each other like translucent photographs exposed on the same frame. Each possibility carries a certain probability, a weight in the cosmic scales, but none of them is more real than the others until measurement collapses this symphony of possibilities into a single, definite outcome. Picture a coin spinning in the air, caught in that moment between heads and tails. In our everyday world, we know the coin is either heads or tails at any given instant, even if we can't see which. But in the quantum realm, that spinning coin would literally be both heads and tails simultaneously, existing in a superposition of both states until it lands and we observe the result. But here's where the mystery deepens into something almost spiritual. The act of observation doesn't just reveal which state the particle was in, it actually creates that state. Before measurement, the particle wasn't secretly in one state or another, hiding its true nature from our instruments. It was genuinely, literally, mathematically in all possible states at once. Reality, at its most fundamental level, appears to be a collaboration between the possible and the actual, mediated by the mysterious bridge of conscious observation. This leads us to one of the most profound questions in all of science and philosophy. What exactly constitutes an observation? Must consciousness be involved, or is any interaction sufficient to collapse the superposition? If a tree falls in a quantum forest and no conscious being hears it, does it make a sound? Or more precisely, does it fall in any definite direction at all? Some interpretations of quantum mechanics suggest that consciousness plays a fundamental role in the collapse of quantum possibilities. The idea that mind and matter are not separate phenomena but aspects of a single, deeper reality that we glimpse in the quantum measurement process. It's as if the universe requires witnesses, as if consciousness is not just a byproduct of complex physical processes, but a fundamental feature of reality itself. Others argue that decoherence with the environment is sufficient to cause collapse, that the quantum system doesn't need conscious observers, just interaction with the larger world. But this raises its own mysteries. If every interaction causes collapse, how do quantum effects survive long enough to be observed at all? How does the universe maintain its quantum coherence in the face of constant environmental interference? Recent experiments have pushed these questions to their limits. Scientists have observed quantum superposition in objects large enough to see with the naked eye, molecules containing thousands of atoms existing in multiple states simultaneously. They've created quantum superpositions that persist for minutes or even hours, as if reality is learning to hold multiple possibilities in suspension for longer and longer periods. What strikes me most about these discoveries is how they challenge our most basic assumptions about the nature of existence itself. If large objects can exist in superposition, if the boundary between the quantum world and our everyday experience is more fluid than we imagined, then perhaps the sense of definiteness we feel about our own existence is itself a kind of illusion. Maybe you, sitting there listening to this, are existing in a superposition of states right now. Maybe there are versions of you that turned off this video, versions that fell asleep, versions that had completely different thoughts in response to these words. Maybe consciousness itself is the universe's way of selecting which branch of reality to experience from the infinite garden of quantum possibilities. This possibility becomes even more intriguing when we consider the phenomenon of quantum decoherence, the process by which quantum superpositions gradually decay into classical, definite states through interaction with the environment. It's as if the universe has a kind of attention span, able to hold multiple possibilities in mind only for brief moments before the complexity becomes too much to maintain, and reality settles into a single stable configuration. But even decoherence raises profound questions about the nature of time and causality. If quantum superpositions decay gradually, rather than instantaneously, then there might be moments when reality is partially collapsed, existing in a twilight state between pure possibility and definite actuality. What would it feel like to exist during such moments? Would consciousness flicker between different versions of reality? These questions lead us to one of the most beautiful and bewildering aspects of quantum mechanics, the many worlds interpretation, which suggests that all quantum possibilities are equally real, and that measurement doesn't collapse superpositions, but rather selects which branch of an infinitely branching multiverse we experience. In this view, every quantum measurement creates new universes, each containing a different outcome. If this interpretation is correct, then every quantum event in the universe is constantly creating new realities, new versions of ourselves, new possibilities for how existence unfolds. The photon that hits your eye as you read these words might have created countless new universes, each with slightly different versions of this moment, this thought, this very sentence. I often wonder whether we might occasionally glimpse these other branches of reality in moments of déjà vu, in dreams that feel more real than waking life, in the uncanny sense that we've lived through certain moments before. Perhaps consciousness is not confined to a single branch of the quantum multiverse, but somehow exists across multiple realities simultaneously, creating the subjective experience of continuity from the objective reality of constant branching. This brings us to another mystery that haunts the quantum realm: the question of quantum consciousness itself. If our brains are quantum systems, if consciousness emerges from quantum processes in neural microtubules or other biological structures, then perhaps our thoughts and experiences exist in superposition until the moment we become aware of them. Maybe the stream of consciousness is not a single flowing river, but a quantum superposition of all possible thoughts, with awareness serving as the measurement that collapses this mental possibility space into specific experiences. This would mean that the thoughts you're having right now, as you listen to these words, were selected from an infinite space of potential thoughts through the mysterious process of conscious observation. Recent research in quantum biology has revealed that quantum effects play crucial roles in photosynthesis, bird navigation, and possibly even human cognition. It's as if life itself has learned to harness the strange properties of quantum mechanics, to exist in the spaces between classical and quantum reality, where the impossible becomes not just possible, but necessary for survival. The idea that consciousness might be fundamentally quantum opens up extraordinary possibilities for understanding the nature of subjective experience. If quantum effects are indeed responsible for consciousness, then perhaps the hard problem of consciousness, how subjective experience arises from objective physical processes, dissolves into a deeper recognition that subjectivity and objectivity are not separate phenomena, but complementary aspects of quantum reality. This quantum view of consciousness suggests that when we experience the collapse of a quantum superposition, we're not just observing a physical process, but participating in the fundamental creativity of the universe itself. Each moment of awareness becomes a moment of cosmic choice, a selection from infinite possibilities that shapes not just our personal experience, but the very fabric of reality. But perhaps the most profound implication of quantum superposition is what it reveals about the nature of identity itself. If particles can exist in multiple states simultaneously, if consciousness might involve quantum processes, then what does it mean to be a single, continuous self? Are you the same person who began listening to this video? Or have you been transformed by each quantum measurement, each collapse of possibility into actuality? Maybe personal identity, like quantum superposition, is not about being one thing or another, but about existing in a state of creative possibility, constantly collapsing and reforming through the mysterious alchemy of consciousness and choice. Perhaps the self is not a fixed entity, but a dynamic process, a continuous creation emerging from the quantum foam of pure potential. As we venture deeper into these mysteries, we discover that quantum superposition is not just a curious property of very small particles, but a window into the fundamental creativity of existence itself. It reveals a universe that is not mechanical and predetermined, but alive with possibility, constantly creating itself through the mysterious interaction of consciousness and cosmos. And in that constant creation, we find ourselves not as passive observers of a fixed reality, but as active participants in an ongoing cosmic improvisation, where every moment offers infinite possibilities, and every choice shapes the very nature of what becomes real. The ancient mystics spoke of reality as a dance between form and emptiness, between the manifest and the unmanifest. And perhaps quantum superposition is simply the modern scientific expression of this eternal wisdom. A recognition that at the heart of existence lies not solid matter, but infinite creative potential, waiting patiently for consciousness to collapse it into the beautiful, temporary patterns we call reality. But our journey through quantum strangeness has revealed an even deeper mystery, one that challenges not just our understanding of particles and waves, but our most fundamental assumptions about the nature of time itself. Because if the future can reach back to influence the past, if quantum effects can operate outside the normal flow of temporal causality, then perhaps time is not the river we imagine it to be, but something far stranger and more malleable. As we stand at the threshold of understanding, gazing into the quantum abyss that challenges everything we thought we knew about existence, we discover that our journey has only just begun. Each mystery we've explored opens doors to even deeper enigmas. Each answer reveals new questions that pulse with possibility. When light forgets to travel, it whispers to us about the nature of reality itself. In those impossible moments of superposition, in the ghostly dance of virtual particles through empty space, in the strange embrace of quantum entanglement across impossible distances, we glimpse something profound about the universe we call home. Perhaps the most beautiful revelation is that we are not separate from these quantum mysteries. We are expressions of them. Every thought that arises in your mind, every moment of awareness, every gentle breath you take as you listen to these words, may itself emerge from the same quantum processes that allow light to exist in multiple places simultaneously, that permit particles to tunnel through barriers they should never cross. The ancient question of whether consciousness creates reality or reality creates consciousness dissolves in the quantum realm, revealing itself as a false distinction. Instead, we discover something far more beautiful. Consciousness and cosmos arise together, two aspects of a single, deeper mystery that expresses itself through the endless creativity of quantum possibility. When you close your eyes tonight and drift towards sleep, remember that you carry within yourself the same quantum fields that fill empty space with virtual particles, the same wave functions that allow photons to dance between particle and wave. Your dreams may themselves be quantum superpositions of possibility, collapsing into specific experiences only in the moments of semi-conscious awareness that flicker through the night. The universe, we discover, is not a cold, mechanical clockwork, but a warm, living mystery that thinks and dreams through beings like us. We are the cosmos becoming conscious of itself, reality learning to observe its own quantum nature through eyes that sparkle with stardust and minds that pulse with the same creative potential that transforms emptiness into matter, possibility into actuality. And so our gentle journey through quantum mysteries comes full circle, returning us to that original moment of wonder when light first forgot how to travel. But now we understand that light never truly forgets anything. It simply follows deeper rules than we imagined, dancing to music we're only beginning to hear, painting pictures of reality that grow more beautiful the closer we look. These quantum mysteries remind us that wonder itself might be the most fundamental force in the universe, the quality of consciousness that collapses infinite possibility into the specific miracle of this moment, this breath, this quiet recognition that existence is far stranger and more beautiful than we ever dared imagine. Thank you for joining me on this sleepy exploration of the impossible. Sweet dreams, fellow quantum travelers, and may your rest be filled with the gentle certainty that mystery and magic are not separate from science, but woven into its very heart. If you enjoyed this journey into the quantum realm, you might find yourself curious about another beautiful impossibility: how time itself might not flow the way we think it does, and what that reveals about the nature of memory, dreams, and the stories we tell ourselves about the arrow of causality. But that's a mystery for another quiet evening, another gentle dive into the waters of wonder. Until then, sleep well, knowing that you are both observer and observed, dreamer and dream, in the endless quantum story of existence itself.